Today we're going to talk about characteristics of graphs. Okay, so a parent function is a set of basic functions used as building blocks for more complicated functions. If you remember, they have no transformations applied to them. Okay, so a function with a connected graph is said to be continuous. Okay, so that has continuity. So, but I like to use the word continuous. So what does that mean? That means if I start drawing on the graph, I never have to lift my pencil in order to finish it. So it is connected every spot. So this one here would be yes. But then if I go to the next graph, I can draw this first one, and that part is continuous. But in order to complete the graph, I would have to lift my pencil. So that is not a continuous graph. So that is no. And then the last one is yes. So you should know what a continuous graph means, and then our parent function. All right, let's look at our x-intercepts. X-intercepts is the point at which the graph crosses the x-axis. Okay, when we know the x-intercept, we know y is always 0. So if we look here, we have 1, 2, 3 x-intercepts. So it's where the graph crosses the x-axis. Okay, so if we label those points, we have -3, 0, 1/2, 0, and 4, 0. So make sure that you understand that the intercepts are points on the graph, and the x-intercept is where the graph crosses the x-axis. Now, if you recall, there is other words that's used for x-intercepts. The x-intercept is one word, solutions, roots, and zeros. So all of those are words used for x-intercept. Okay? The y-intercept is the point at which the graph crosses the y-axis. We look at this graph, that's going to be that point right there. And when we know the y-intercept, we know that x is always 0. Okay, so the y-intercept here is 0, 2. If you recall, this is a linear function. It makes a straight line. Then we have a local maxima. So that is the highest point on a graph in a given area. Okay, you can have more than one maximum and minimum. Okay, so in this case, these two are the maximum points. If we label those, this first one would be at -3, 3. And the other one is at 3, 2. Now this one right here is the absolute highest point the graph goes on. So we can call that an absolute maximum. Okay, so you can have more than one maximum and you can have an absolute. Now, this one here is called a local, but you don't have to label it as a local. Okay, so a minimum is the lowest point on a graph in a given area. So in this case, there's only one. You can have more than one though, and it's 0, -4, and it is the absolute lowest point on this graph. Okay, if you recall, this is a quadratic function. We call this graph a parabola. So that 0, -4 is also known as our vertex for this graph. And then if you think about what we just learned, since it crosses the y-axis, it is also our y-intercept for this graph. Now let's talk about what we can remember from parabolas. Okay, if we look at this graph, we will notice that it has two x-intercepts. Okay, that means two solutions. We have one at -3, 0, and the other one is at 3, 0. Okay, so on your homework, you're going to be asked to label parts of a parabola. So you may have zeros, which are also known as x-intercepts, the vertex, the y-intercept, and it may ask you for the axis of symmetry. That is an equation, and it is an imaginary line that divides the graph in half. See, it's symmetrical. This point is symmetrical to this point, and so that's what that does. So it is always x equals whatever the value is at the vertex. So in this case, it's 0. Okay, so these are things that hopefully you have seen before, and we will be spending some time reviewing this in the next couple of days also. So let's look at this next part, interval of increase and decrease. So first of all, let's review our graph. When we review our graph, I hope you remember that you always read a graph left to right, and then we read bottom to top. Okay, on the left side, we have negative infinity. And then as you move to the right, you go to positive infinity. And then from the bottom, we have negative infinity. And as we go up, we go to positive infinity. Okay, so if you always just remember, you start with a negative infinity, you don't have to worry about left to right, top, bottom to top. You can just go negative infinity. Okay? When you're dealing with interval of increase and decrease, we're dealing and looking at the x values only. So we're looking at how far we have traveled. So let's look at our little walk here. Okay, we start here at 0 and we are going uphill until we hit 2. Okay, what are we doing there when a person is walking uphill? The graph is increasing. Then at 2, we start going downhill until we reach 6. And at that part, we are decreasing. Now, I want you to think about when you go hiking. Okay, when you get up to the top of the hill here, once you're at the top of that hill, you're not walking up or down. Okay, you're neither increasing or decreasing at that. That's the point of change in direction. I go from increasing to decreasing, but I'm not increasing there or decreasing. So when the person's at the top or the bottom of the hill, they are neither increasing nor decreasing. So we use parentheses to label increase and decrease instead of brackets. Okay, so let's go back to our graph. If we continue to walk, we are going to increase, and since there's an arrow at the end of this, it means it's going to go on to infinity. So let's label our interval of increase. So we started here at 0 and we go to 2 using parentheses. That is increasing. And then we are decreasing from 2 to 6. And then at 6, we start increasing again, and that's to infinity. And sometimes you will see a U between, so that means that they're union, okay? So the key thing about increase and decrease is you're looking whether the graph's going up or down, And then you're finding how far left to right we traveled. So in this case, from 0 to 2 and 6 to infinity, we were increasing, and 2 to 6 decreasing. Now the end behavior describes what is happening to our f of x, or also known as y, as x gets very small or very large. Okay, so let's look at this first one. As x is going to the left, because we always read the graph left first, what happened to y? It went down. So that's going to be negative infinity. As x goes to the right, what did y do? It went down. So that's also going to be negative infinity. So here you can see that both of the end behaviors went down, and we're using negative infinity to show that. Okay, if we look at this one, they're not both going to negative infinity. One's going up, one's going down. So you always start as x goes to negative infinity. So what happened to y? It went to positive infinity because it was going up. And then as x goes to positive infinity, y was going down. All righty. An asymptote is a line that the function approaches but does not touch. So here we have the asymptote x equals 0, and that is a vertical line. So that is a vertical asymptote. And then we also have y equals 0, which is a horizontal asymptote. So those things we'll be talking about more, but you can see that the graph gets really close to those lines, but they don't touch them. All right, domain, what values do you use for domain? We use x values. And then for range, we look at the y values. So again, left to right, how far does the graph go from left to right? And bottom to top. All right, so that's the end of the notes for today. I did flip over and I just used this chart. I did not do this problem. And we talked about some domain and range. So I'm going to go through a couple of these just so that you make sure you understand these. All right, so here, the domain. If we look at this graph, it goes off to the left, continue because of that arrow, and to the right forever. So our domain would go from negative infinity to positive infinity, and also is all real numbers. Our range, this is the lowest point, okay? Right here is the lowest point. So that point is 1, 2, 3, 1, 2. So negative 3, negative 2. So how far down does that graph go? How far down? To negative 2. Is it included in there? Yes, it is. So we're going to put a bracket, negative 2. And how far up does it go? Infinity. So that it would be how you would do the domain and range for that type of graph. Okay, so let's look at another one. What if we had a graph like this. Okay, so first of all, this pair here would be 1, 2, 3, 4, 1, 2. So this ordered pair here would be -4, -2. Okay, so that one there. And then this point over here is 1, 2, 1, 2, 3. So then the point 2, 3. Now you'll notice one of these is a closed circle and the other is open. Closed circles we use brackets for. Open we use parentheses. So we're going to start with the domain. How far left of this graph? So you can think of this, if you wanted to, you could highlight this. And then we would be able to see that it went down to there. And you could see the part there. So it only would go to this part here from left to right if we were thinking left to right. Okay, so how far left did it go? Right here to -4, and that's a closed dot, so it'll be a bracket. And then we went to the right, okay, to 1, 2. But that one's open, so it's going to be a parenthesis. Okay. Then if we wanted to look at how far down to up it went. Okay, so we're going to look up and down. So we're going to look up and down. So in that case, we're going to go from -2, that's the lowest part here, up to 3. That's how high it went. So we're looking at the distance from bottom to top. Okay, where did it start? So here at -3 is a closed, and it went up to +2, and then that would be that. So that would be our domain and range. All right, sometimes we have stuff that looks like this. Hold on, let me put these in little. Now we're good. All right, in this case, our domain on the left side, 1, 2, 3, 4, 5. So -5, and it's a closed circle. And then all the way from -5 to the right, 1, 2, 3, 4. So that's going to be at 4, and that's going to have a bracket because that circle is open. Okay, so then how low did it go? It went down to -2. And again, that's going to be a bracket. Now, some of you want to look at the end point again here, but that's not the highest point. Okay, the highest point's right here. So it went up to +2, but that is part of the graph, so it would be a bracket also. So this 1 is an end point here, but it is not the highest point, so we don't use it for the range, but we did have to use it for the domain because it was the furthest to the right. All right, please check Planbook for your assignment, and I hope you have a good day.